GFI and GFCI are actually the same thing. GFI stands for Ground Fault Interrupter, while GFCI stands for Ground Fault Circuit Interrupter. Both terms describe a device designed to detect ground faults and quickly interrupt the circuit to prevent electrical shock. These devices are crucial for electrical safety. GFI and GFCI devices work by monitoring the current flowing through a circuit. They specifically compare the current flowing through the hot wire and the neutral wire. Under normal circumstances, these currents should be equal. If a difference exists between the current in the hot wire and the current in the neutral wire, it indicates that some current is leaking to the ground. This leakage is known as a ground fault. A ground fault can occur due to a short circuit or a fault within an appliance or the wiring itself. The danger of a ground fault is that the leaking current can flow through a person who comes into contact with the faulty appliance or wiring, resulting in a potentially lethal electrical shock. When a GFI or GFCI device detects a ground fault, it acts rapidly to interrupt the circuit. The interruption occurs within a fraction of a second, typically around 0.3 seconds. This rapid response time is critical in preventing serious injury or death. By quickly cutting off the power supply, the GFI or GFCI device prevents the current from flowing through the body of the person who is in contact with the faulty equipment. The National Electrical Code, or NEC, mandates the use of GFI and GFCI protection in specific locations. These locations are typically areas where there is a higher risk of electrical shock, often due to the presence of water or dampness. Some common locations where GFI or GFCI protection is required include bathrooms, kitchens, garages, and outdoor areas. The specific requirements may vary depending on the particular edition of the NEC and local building codes, so it is essential to consult the most up-to-date regulations for your area. GFI and GFCI devices are available in several forms. Outlets are the most common and easily recognizable. These are installed in place of standard electrical outlets and provide GFI or GFCI protection at that specific location. A GFI or GFCI circuit breaker can be installed in the electrical panel. It provides protection for the entire circuit that it controls. This is a good option for protecting multiple outlets or appliances on the same circuit. Portable GFI or GFCI devices are also available. These can be plugged into a standard outlet and provide protection for any equipment plugged into the portable device. These are often used in construction sites or other temporary locations. Testing GFI and GFCI devices regularly is crucial to ensure they are functioning properly. Most GFI and GFCI outlets have a test button. Pressing this button should trip the device, cutting off power to the outlet. There is also a reset button that restores power after the device has been tripped. It is recommended to test GFI and GFCI devices at least once a month. If a GFI or GFCI device fails to trip when tested, or if it trips frequently for no apparent reason, it should be replaced by a qualified electrician. The 2-pole 30-amp breaker, the 15-amp circuit breaker, and the G controller should all have GFCI protection where appropriate. First, receptacles should be GFCI protected according to code. Second, circuit breakers of 15 amps or 30 amps should be GFCI protected where required by code. Third, the G controller should have GFCI protection where mandated by code. GFI and GFCI devices are designed to protect people from electrical shock. They do not protect against overloads or short circuits, which can damage equipment or cause fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect against these types of faults. It is important to use the correct type of protection for each situation. While GFI and GFCI devices are effective at preventing electrical shock, they are not a substitute for safe work practices. Always follow safe work procedures when working with electricity. To energize circuits before working on them. Use insulated tools and equipment. Avoid working in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. GFCI receptacles typically have a test and a reset button located on the face of the receptacle. The test button is used to simulate a ground fault and verify that the GFCI device is functioning properly. When the test button is pressed, the GFCI device should trip, cutting off power to the receptacle. The reset button is used to restore power to the receptacle after the GFCI device has been tripped. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. The receptacle must be properly grounded in order to function correctly. If you are not comfortable installing a GFCI receptacle yourself, hire a qualified electrician. There are different classes of GFCI devices, each designed for specific applications. Class A GFCIs are the most common type and are used for general purpose protection. They trip when a ground fault of 6 mA or more is detected. Class B GFCIs are used for specialized applications, such as protecting underwater lighting. They trip at a higher ground fault current level than Class A GFCIs. Class C, D, E, and F GFCIs are used for even more specialized applications and have different tripping characteristics. When selecting a GFCI device, it is important to choose the appropriate class for the application. GFCI circuit breakers provide protection for an entire circuit rather than just a single outlet. They are installed in the electrical panel and provide the same level of protection as GFCI receptacles. GFCI circuit breakers are a good option for protecting circuits that serve multiple outlets or appliances, especially in areas where GFCI protection is required by code. When installing a GFCI circuit breaker, it is important to follow the manufacturer's instructions carefully. The circuit breaker must be properly wired in order to function correctly. If you are not comfortable installing a GFCI circuit breaker yourself, hire a qualified electrician. The sensitivity of a GFCI device refers to the amount of ground fault current that is required to trip the device. Class A GFCIs, which are used for general purpose protection, have a sensitivity of 6 mA. This means that they will trip when a ground fault current of 6 mA or more is detected. Some specialized GFCI devices have different sensitivities. For example, Class B GFCIs, which are used for protecting underwater lighting, have a higher sensitivity. The appropriate sensitivity for a GFCI device depends on the specific application. The tripping time of a GFCI device refers to the amount of time it takes for the device to trip after a ground fault is detected. GFCIs are designed to trip very quickly, typically within a fraction of a second. The maximum tripping time for a Class A GFCI is 0.3 seconds. This rapid response time is critical in preventing serious injury or death from electrical shock. The reset level of a GFCI device refers to the amount of time that the device must remain tripped before it can be reset. This is to prevent the device from being immediately reset after a ground fault, which could be dangerous if the fault is still present. The reset level for a typical GFCI device is a few seconds. Surge protection is a separate type of protection that protects electronic equipment from voltage spikes. Surge protectors do not protect against ground faults and are not a substitute for GFCIs. It is important to use both surge protection and GFCI protection to protect both people and equipment. Arc fault circuit interrupters, or FSIs, are another type of circuit breaker that protects against fires caused by electrical arcs. FSIs detect arcing faults, which can occur when wires are damaged or connections are loose. FSIs do not protect against ground faults and are not a substitute for GFCIs. It is important to use both FSIs and GFCIs to protect against both electrical shock and fires. In addition to testing GFCIs monthly, it is also important to visually inspect them regularly for any signs of damage or wear. Look for cracks, discoloration, or loose connections. If you notice any problems, replace the GFCI immediately. GFCIs have a limited lifespan and may need to be replaced after a certain number of years, typically around 10 to 20 years. The lifespan of a GFCI can be affected by factors such as the frequency of use, the environment in which it is installed, and the quality of the device. If you are unsure when your GFCIs were installed, it is a good idea to have them inspected by a qualified electrician. Grounding is an important part of electrical safety. A properly grounded electrical system provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. GFCIs protect against ground faults that occur when current leaks to ground through a person's body. While grounding is important, it does not provide the same level of protection as a GFCI. GFCI protection is always recommended in areas where there is a risk of electrical shock. Double insulation is a safety feature that is used on some electrical appliances. Double insulated appliances have 2 layers of insulation between the electrical components and the outer casing. This provides an extra layer of protection against electrical shock. Double insulated appliances do not require grounding, but they still benefit from GFCI protection. GFCI protection will protect against ground faults that could occur if the double insulation fails. Portable GFCIs are a convenient way to provide GFCI protection when a permanent GFCI outlet is not available. Portable GFCIs can be plugged into a standard outlet and provide GFCI protection for any equipment plugged into the portable GFCI. Portable GFCIs are often used in construction sites, workshops, and other temporary locations. When using a portable GFCI, it is important to follow the manufacturer's instructions carefully. The portable GFCI must be properly plugged in and grounded in order to function correctly. Extension cords can be a safety hazard if they are not used properly. Never use extension cords as a permanent wiring solution. Extension cords should only be used for temporary purposes. When using an extension cord, make sure that it is the correct gauge for the appliance that you are using. A heavier gauge extension cord is required for appliances that draw more current. Never overload an extension cord by plugging too many appliances into it. Inspect extension cords regularly for any signs of damage or wear. Replace any damaged extension cords immediately. Lockout-tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. Lockout-tagout procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch. This prevents anyone from accidentally turning the power back on while someone is working on the equipment. Lockout-tagout procedures are essential for electrical safety. Always follow lockout-tagout procedures when working on electrical equipment. Qualified electricians should perform electrical work. Working with electricity can be dangerous. It is important to have the knowledge and skills necessary to perform electrical work safely. If you are not comfortable working with electricity, hire a qualified electrician. A qualified electrician will be able to perform the work safely and correctly. They will also be able to identify any potential hazards and take steps to mitigate them. They can also ensure the electrical system meets all applicable codes and regulations. Permits may be required for some electrical work. In many jurisdictions, a permit is required for certain types of electrical work, such as installing new wiring or replacing an electrical panel. Permits are required to ensure that the work is done safely and in accordance with applicable codes. Contact your local building department to determine whether a permit is required for your project. Inspections are often required after electrical work has been completed. An electrical inspection is performed by a qualified inspector to ensure that the work has been done safely and in accordance with applicable codes. If the inspection is approved, the inspector will issue a certificate of compliance. This certificate is required to obtain a final occupancy permit for the building. Electricity is essential for modern life, but it can also be dangerous. By following safe electrical practices, you can protect yourself and your family from electrical shock and fire. Always be aware of the potential hazards of electricity and take steps to mitigate those hazards. If you are unsure about anything, consult a qualified electrician. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before performing any electrical work. The NEC, or National Electrical Code, is a set of standards for electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is widely adopted by state and local jurisdictions and is used to ensure the safety of electrical systems. Compliance with the NEC is essential for electrical safety. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is a complex document, and it can be difficult to understand and apply. It is important to consult with a qualified electrician or other professional to ensure that your electrical system complies with the NEC. In addition to the NEC, there are other electrical codes and standards that may be applicable to your project. These codes and standards may be adopted by state or local jurisdictions or may be required by insurance companies or other organizations. It is important to be aware of all applicable codes and standards and to ensure that your electrical system complies with them. Continuous learning and updates on electrical codes and safety practices are very important. Electrical codes and safety practices are constantly evolving. It is important to stay up to date on the latest changes and to continuously learn about new technologies and techniques. There are many ways to stay informed about electrical codes and safety practices, such as attending training courses, reading industry publications, and consulting with qualified electricians. Continuous learning is essential for electrical safety. Electrical safety is a shared responsibility. Everyone has a role to play in ensuring electrical safety. Homeowners, renters, business owners, and employees all have a responsibility to be aware of the potential hazards of electricity and to take steps to mitigate those hazards. By working together, we can create a safer electrical environment for everyone.